Hello, this is Aaron for Chef. In this video, I'm going to show you how to optimize the simulation of your agent group. So I create a simple example here with a single agent group that's using a grid layout and state machine. So let's increase the number of the agent here to, I don't know, 70 by 70 or 5,000. Just press play. Just add the stat. Oh, sorry, stat unit. I also add the atom stat. Stat atoms crowd. For the stats, you can see the compute pose is the actual atom simulation. The extract pose basically is the function that is extracting the word transformation of each joint and do the culling and a couple of more data extraction. And then the update render data is the time spent by Atoms to update the vertex buffer to send that is used by the shader to draw the agents. So now, as you can see, we have 10 milliseconds of simulation. Update render data is 2 milliseconds and 1 millisecond. So let's go on the Atoms agent group. For now, let's move and set as idle states. Okay, so let's go here. So the first thing that you can use to optimize the simulation is to simulate only visible agents. This means that only the agents that are visible inside the frustum is simulated at each frame. So we can turn on this one, and let's have a look how the compute pose change. Now you can see is much lower because it's simulating only the visible agents. If I, for example, go here, you see they just go everything to 0. Obviously, for static agents like in Stadium or agent in idle, it's really useful. But if they are working agents, then probably is not the best solution. But it really depends on your situation. For example, if I use the wall clip, you can see now the agents are working. But if I turn, you see there are a lot of overlapping agents because the other agents are not simulated. As you can see now, all of the agents are simulated. As you can see, it really depends on your scene. Usually it's really helpful with agents that are in idle pose, for example in a stadium scene or a scene like that. So let's switch back to the state. Let's put in idle. So let's have a look again to the FPS. So it's 5 milliseconds. Extract pose is 2 milliseconds. So in scene like this, where for example stadium scene where the agents are in idle, you can turn on another optimization that use a static bounding box. This means that Atoms doesn't compute at every tick the bounding box of the agents, but just use the initial bounding box. For example, for agents like this that are in idle, usually the bounding box is almost the same to every frame. So we can turn on this one. Let's have a look if we. So it's now extract pose is. Let's see with full agents, 3 milliseconds. If I turn off the use stack bounding box, yeah, as you can see, there are 3.5, 3.4 maximum millisecond. So let's turn on this guy. Okay, the other parameter that you can use is the maximum simulation distance. This means that the agents that are closer to this radius are simulated. So, for example, let's exaggerate and put a really low value, I don't know, 1000. The fade-in is using for material properties that I show in a bit how to use it, but not for simulation. So let's put to 200 and let's have play. Now you can see the complete pause is just 1 millisecond because it's just simulating the agents are inside the radius of 1000. In this case, for cases like this, it's fine. And now basically it's not simulated now. Okay, now let's have a look how to use the fade-in. So if I go to the one of the material, this, let's use the fade-in per instance, fill amount, and for example multiply this guy. That's it. As you can see now, the that node is passing 1 for the agents that are active and 0 for the agents that are not simulated. The fade-in basically just blend this value between 1 to 0. So if I do, for example, let's put 800, let's see if you can see a difference. Yeah, you can see there are, the fade-in is just used to blend that value a bit. This is exact for, in this way you can use that node to control, I don't know, some customization in the material for the agents that are not active. I don't know, adding, I don't know, some noise or some kind of trick to make the agent like animated. Okay, the last thing that you can use to speed up the simulation is to use the enable tick interval. This means that the Atom simulation is not called at every tick, but is called only a specific time. So if I activate this one, now basically Atoms will compute the pose of agent at a rate of 30 frames per second, because this value is 1 divided 30. So if I press play, yeah, let's have a look at the start FPS. It's too fast. Let's disable all the optimization here. It's too fast again. Sorry, let's remove this guy. Okay, now see is 40 frames per second, and if I turn on the tick interval, yeah, it's faster because it's not compute the pose of the agent at every tick, but only with the frame rate of 30 frames per second. So that's it. Thank you for watching and see you in the next video.